For number 1 here, create the function and state the domain and range of this graph. Can you tell that this graph is a square root graph? All right. The equation for a square root graph is y equals a, the square root of x minus h plus k. So before we figure this out, we have to figure out what hk is and what a is. In order to find the equation, can you tell we need hk and a? And in order to find that, are we okay with that being hk? Can you think of this as a sideways parabola, half of a sideways parabola? Isn't that kind of like your vertex? If the parabola is on its side, that's the bottom half of a parabola on its side. So this would actually be the vertex of that sideways parabola, which is hk. So what is that coordinate? Well, let's first label this. That's hk, just so it reminds you. Make sure you label that, just so you remember that dot right there on the edge is hk. And what would that value be? Or what would that coordinate be? If we look at the graph, it is -3, 4. Now the a value is a little bit harder. We know our hk. Could we stick that into the formula? But let's find a. Now think back to graphing parabolas. Since this is just a parabola on its side, do you remember our a value? When you went one step to the right and left, you went a value up or down? Do the same thing. From here, when I go one step to the right, how far down until I hit the graph? 2. So as I go over 1, I went down 2. So that is an a value right there. When you go over 1, how far up or down you go is your a value. Now, is this in the negative or positive direction of 2? So we have a -2 there. Whatever your a value is, when you go one step to the right, how far up or down. Now, that pattern does not keep working. It only works one step. But do we have everything we need for the equation? Yeah. I now know my equation is -2 square root of x. The opposite of -3 is a +3 plus 4. So there we go. There is my equation for this specific graph. Now when you do your homework, you're going to get an equation and you graph it. But for this one, I gave you the graph and I want the equation. Now the last part says domain and range. My domain range. My domain, can you tell my domain starts here at -3 and goes to the right forever? Yeah. There's different ways of writing it. We're going to call our D for domain is going to be starting at -3, including it, to infinity. You could also write it as x is greater than or equal to -3. There's two different ways you could write the interval. One's interval notation, one's just kind of all the values of domain.
Will we be having to do that?
Either way. On a test, they could write it either way. They might write it one way or the other. It's not. I'm not picky on which one exactly you're writing it in. For your range, can you tell your range? It's a high. Is there any values going to be above 4?
No.
So your range is going to be from -infinity to 4, because you have to remember you always go from smallest to largest. And so your smallest is -infinity all the way to 4. Otherwise, you would write it as this. Are we okay? Your y values are below or equal to 4. Now I want to highlight something. Why? Let's think about our domain. Why is our domain not exist over here? Well, what's x value? Do you understand -4 does not have any graph? -5 does not have any graph. Watch what happens if I try to put -4 in the function. What's -4 plus 3? -4 plus 3 is -1. What's the square root of -1? 1. The square root of -1 is I. And are we having issues with complex numbers? It's not real. So do you see how it's not going to be graphing? Because every value you plug in over here comes out to be imaginary. So there's an issue. So that's why there's no graph over here. Now, for a cube root, let's find h, k, and a. Actually, before we even do that, can we write it as this? Just so you have it kind of written out nicely. Write that down. And then what we're going to do is we're going to find HK. What's that coordinate and what's A? By looking at the equation we're given. By looking at this, we're going to find HK and A. So my HK is going to be these two numbers, which is this and this. Remember, H is always opposite. So it looks like it'd be a -4, -5 is my H. And my A value is a number in front, and that'll be a -1. So let's graph this. Can I put the coordinate -4, -5? -4, -5, right there. And to graph this, your A value is -1. So one thing I want to point out when you graph this is if A is -1, do you understand we're going to go over 1 and down 1? So we have a dot right there to start with. So we have a dot right there. Now, from there, do you understand it will look kind of like a square root graph, but it'll be narrower. It kind of keeps going down, but it's a square root graph, but narrower. But doesn't it also have an opposite leg to it on a cube root? So what we're also going to do is, aren't we going to go up 1 over 1 and put your opposite kind of flipped leg over this way? Leg's maybe not the best word, but we're going to take that value and go up 1, over 1, up 1, and put a dot right there and make the graph also like that. So a cube root is kind of like graphing a square root with another one going the opposite direction, but it's always narrower than a square root. Cube roots will always be a little bit narrower. Now, could I plug in values to get more dots? Yeah, I could plug in any value I want to find more accurate dots. We're going to just sketch. We're sketching with the A and the HK just to get a basic look. And we're done. If this was a positive A value, do you understand it would look kind of like that? Hopefully. Now, domain range is kind of pathetic. Think about why domain range is like, that's too easy. What's your domain? Everything. What's your range? Is this graph going to keep going up, up really slowly? Won't this graph keep going down, down, down very slowly? So why I think this is kind of pathetic is, isn't your domain just all real numbers? And what do you think your range is?
The same as your domain.
The same, all real numbers. As long as you can memorize that, you're done. So for a cube root, it's always going to be that way. There's nothing you can plug into a cube root to error it. It'll always get numbers out. So your domain range on any cube root is always everything. But on a square root, you have restrictions due to imaginary numbers. You cannot have imaginaries, negatives in a square root, so that's why it only has a part, and your domain range is restricted more.